Happy Earth Day, everyone. Thank you so much for inviting our group to talk with you today. My name is Heather Hopkins, and I am the program coordinator at Strong Coasts, based at the University of South Florida. So first, I am going to give a brief introduction to our program, and then we do have a few of our students here to talk about how they're applying science to the real world and dealing with real challenges and issues, and how their research is helping to protect coastal systems in many parts of the world. So our program, Strong Coasts, is a team of faculty and graduate students from both the University of South Florida and the University of the Virgin Islands. So you can see our graduate students here in this slide, and you can also see where we are, we focus a lot of our work and where we're based. So of course, you know where Tampa, Florida is here. We have the University of the Virgin Islands in this tiny little island here that you can't even see on this map. Then we also have Belize right over here and Barbados right here, all part of the Caribbean. And we focus a lot of our research in those two locations with some partners that we have there. But we also expand around the world, and you'll see later in a presentation from our student that we have other locations that we work in. So our program trains anthropology, environmental engineering, and marine sciences graduate students at both USF and UVI. We train them in community-engaged systems thinking research to better manage food, energy, and water systems in order to increase resilience in coastal areas. So I know that may be an earful. Let me just provide a few definitions for you. So anthropology is the scientific study of humanity. So they're concerned with human behavior, human biology, cultures, and societies in both the present and the past. And environmental engineering is a discipline that takes from broad scientific topics. So anything from chemistry to biology, hydraulics, mathematics, just to name a few. They create solutions that will protect and improve the health and living organisms and improve the quality of the environment. Marine sciences explores how to utilize research to manage natural resources, with a particular focus on the issues and challenges related to natural resource management in our oceans, on the coastlines, and so forth. So students apply to our graduate fellowship program in order to gain support for their research, which must include an interdisciplinary project that considers whole systems rather than an assembly of isolated systems when they're exploring their research questions. We also partner with communities, and that's an essential part of our work, as you can't go into an area and work on the environment without considering the people that live there. So this slide just shows just very few of the many photos that we have of some of the sciencing that our students are doing. We have some sciences, the students that are in a lab. This is like when we went to, I didn't go, I wasn't here yet, but some of our students went to Belize and did both an anthropologic discussion, and then also did some work with the coral reefs there. Also, our students publish their work and they present their work. So we work on a lot of science communication. So this is sort of like when you all are required to do your science project and you have to do a board, and then you have the event where people go around and ask you questions about your project and so forth. So a lot of our students go to actual professional conferences where there might be anywhere from 20 scientists to 2,000 scientists, and they'll come around and ask them questions. And so they get to practice presenting their work. So again, let me just explain a little bit deeper. So what do we mean by a whole system? So our students examine the engineered infrastructure plus the environment, plus sociocultural aspects. And we treat this as a whole system instead of looking at the individual systems separately. So an engineered infrastructure is a system that supports a community. So for instance, like roadways and bridges and, train tracks, and there's a lot that goes into an engineered infrastructure, but also like a wastewater treatment plant. So the wastewater that comes from our homes or our businesses and buildings, it has to be kept safely away from our waterways. It has to be kept safely away from, from drinking water. So that's an engineered infrastructure. The environment can be a local area, or it can be on a larger scale, like along this ridge to reef scale, which is kind of like an inland to the oceans area. And then sociocultural aspects are the common traditions, habits, patterns, and beliefs present in a population group. So again, our students study all of these together as a whole complex system. So let's say, for instance, in this ridge to reef image, we have a village that's near the oceans, and we have a stream, and then back here is actually some mountains. So let's say they want to put in an engineered infrastructure like a wastewater treatment plant. They want to be able to carry the waste, put pipes in and carry it to a treatment plant, and maybe use that water then, like the reclaimed water, maybe use it as an energy source or something. So let's say the only location is to put it like right here, which is near the stream. If the wastewater treatment plant has, let's say all of a sudden a leak occurs, and it starts kind of trickling slowly into this stream over here. Hopefully you guys can see my mouse. So I know you guys can't talk or anything, but just kind of ask this, I would ask this question if we were in person, to have you raise your hand. Like, do you think a solution for that would be that we would just seal up the pipe, clean that tiny little area, and be done? Hopefully you would say, no, because you see this stream flows all the way to the ocean. So now we have all these chemicals that are over here affecting habitats, affecting the fisheries. So this community, the people in the community that rely on the habitats, the fisheries and all that for food, for income, they're going to be affected by that as well. So this is a whole system. You don't just look at the one little area where you need to fix the issue. You've got to look at how it affects all of them and each other. And don't worry, we're not going to quiz you or anything on all of this stuff, but this is just to kind of give you a general idea of what a systems thinking process, how our students go through the process. So we broaden the model to a more circular system. And that can reveal the interconnectedness of our world and how ecosystems are intertwined in more circular patterns of cause and effect. So a systems thinking approach will lead to more comprehensive understanding of global issues. It can lead to more innovative solutions that support sustainability. So as opposed to sticking with traditional thinking where we might have, A and B come together and they produce C, well then C changes to D. And then if we kept on this linear path, just a straight line path, we would say, okay, so now we have D, and let's say we have, E comes together and then that produces, G, and then it equals Z or something like that. It's a linear. Whereas if we stick with the systems model, again, don't worry, you don't have to write this down. You see all these circles. This is not linear at all. You can enter into this systems thinking model at any point. So let's say that this just happens to be a system model for improving a wastewater system near a coast in Belize. So, let's say we want to, a year after this wastewater treatment plant, is put in place, or maybe they've done some innovations. Let's see what the effects are on the fish in the area, because we've noticed that all of a sudden there's too many fish, and it seems like there's not enough algae because the fish are eating the algae. So you can enter into here and see what the nutrient load may be in the water bodies there. That's going to affect the corals. A lot of fish rely on corals for habitat and food sources and many other things. So anyway, so that's just to give you a general idea of the way our fellows are trained to think when they're asking their research questions and going into their research. So I also mentioned food, energy, and water systems. We call this FEWS, F-E-W-S. Sorry, I didn't include that on this slide, but so FEWS systems are interconnected, and human activity related to the generation and the use of FEWS has been linked to impacts that degrade the quality of coastal waters. So for instance, like the wastewater treatment plant, you see how if it trickles into the waters, that could affect the food system in that area. It also could affect the farmlands, and not having enough water. That's, if the waters are all murky and they have chemicals in them, you can't use those to grow food, right? So it's all connected. So our group is committed to finding solutions to complex sustainability challenges, and we partner with communities to explore how food, energy, and water are interconnected and find innovative ways to fix the issues. So I think, I know there's a lot of information. So I have an awesome video that I'm going to play that I think this will help pull all these definitions together. It'll help show you how important it is to work on an interdisciplinary team. Interdisciplinary team is like 2 or more disciplines. So as I mentioned, we have anthropologists, we have environmental engineers, and we have marine scientists. If they all did their own individual research projects, they're working individually. They're kind of, we call it siloed. They're just in their own pockets, right? But if they come together on a project, that's an interdisciplinary team and they can learn from each other. So this video features two of our students that aren't here with us today. Chris-Ann Hines, well, they're going to introduce themselves in the video, but just to give you a heads up, they did some work in the Florida Reef Tract, which is down in the Florida Keys. So let's have a watch and a listen.
My name is Michelle Platts. I'm a doctoral candidate in the Department of Civil and Environmental Engineering at University of South Florida.
Hi, my name is Chris-Ann Hines, and I'm a PhD student in the Department of Anthropology here at the University of South Florida. We're both fellows in the NRT Strong Coasts program here at the University of South Florida, where we are studying how coral reef restoration is impacting the Florida reef tract.
In this study, we're analyzing the community of practitioners and natural resource managers directly involved with coral reef restoration to understand barriers preventing effective coral management and restoration monitoring, and to try to identify ways in which to improve the reef restoration system.
We hope to do this by incorporating both anthropological and environmental engineering perspectives to improve how we're monitoring the coral reef system, as well as improve the relationship between stakeholders and their interaction with the Florida reef tract. Coral reef restoration is a socio-ecological system. This means that we can't understand it completely without understanding both the human dynamics as well as the environmental impacts. To create long-lasting solutions, we need to fully understand what the problem is. And to do this, we need to understand all the different facets of it.
The value of interdisciplinary research is that it enables us to see a more complete picture of the problem. For example, if I look at a problem through my engineering constraints, I might see something that resembles a square. And when Chris-Ann looks at the same problem through her anthropological lens, she sees a completely different set of constraints, and she might see something that looks more like a triangle. So when we put together these multiple dimensions of understanding around a problem and step back, now we see something that resembles a prism, and we no longer see a square or a triangle. And this is what makes interdisciplinary work so valuable. I would not be able to see this whole picture without Chris-Ann's perspective.
Having the opportunity to work with an environmental engineer has really opened my eyes to the ways that we can design some of these solutions that are not just respectful to the communities that we're working with, but also sustainable when it comes to resolving the problems that we're seeing.
As an engineer, the experience of working with an anthropologist has expanded my perspective tenfold. I've really come to understand that the problems I'm working with are not just technological or laboratory or computational, but in order to have a sustainable solution long-term, we really need to also be engineering problems for the society and the people who are implementing those solutions.
Understanding the technical and societal dynamics of the system is emerging as a key component to the next phase of development. One of the things that I love about this project is that it's allowing me to become ahead of the curve when thinking about my future career as an environmental anthropologist. Working with this project has really allowed us to shape the forthcoming methodologies as well as frameworks that will be used by policymakers, managers, and various practitioners in the coral reef restoration and monitoring community.
For more information about our study or about the Strong Coasts program, please visit www.strongcoasts.org. My name is Michelle.
So I want to just pause here for a moment before I introduce the students to do their presentation and just make sure, just see if there are any questions that you have so far, or we do have time at the end for a lot of questions, but I know I just provided a lot of information there. So I'm not sure if any of the teachers have any questions on hand, or if we want to just keep going through. No? Okay, yeah, no problem. Well, like I said, we'll have some time in the end for some questions. So next, I am going to hand it over to our students that are going to introduce themselves, but here are their lovely faces and you will see them on the video as well. So we're going to start off with Allison. Take it away.
Good morning, everyone, and happy Earth Day. Thank you so much for joining us today to hear about all of our exciting research. So my name is Allison Holevolt. I am a first-year master's student here at the University of Rhode Island. My research interests have taken me everywhere from Alaska to Florida and now here to the Caribbean. I've worked in fisheries as well as coral restoration, but today I'm here to talk to you about mangroves. Will you click, please? Thank you. So just to get everyone all on the same page, mangroves are salt-tolerant shrubs and trees that are found in tropical and subtropical areas and especially in Florida. Mangroves play an important role in the environment from that ridge to reef realm that Heather had mentioned. So mangroves protect coastlines from erosion. They lessen storm surge and protect shorelines from those large waves that can be generated. And you can click through, please, Heather. They store atmospheric CO2. So they take CO2 from the atmosphere and store it in the ground that builds up underneath them. They provide habitat for juvenile fish, corals, sponges, and invertebrates. And besides the services they provide, mangroves are very dynamic and interesting ecosystems in and of themselves. Unfortunately, mangroves are facing many global threats, including sea level rise, deforestation and removal for development, pollution, as well as increased damage from storms such as hurricanes. The good news is that mangroves are considered resilient ecosystems, able to bounce back after disturbances and naturally regenerate and recuperate after disturbances. However, persistent disturbance can severely stress out mangroves, can hinder their natural regeneration, and can stop mangroves from being able to recover altogether. Next slide, please. So I am located here on the left map in the US Virgin Islands, which is located under that purple star there. It is made up of 3 islands, St. Croix, St. Thomas, and St. John. I am currently on St. Thomas. Now, back in 2017, there were 2 Category 5 hurricanes that came through the area and did a lot of damage, not only to infrastructure here, such as houses and businesses, but also to the mangrove stands that protect the shorelines. So the mangroves in the US Virgin Islands have been not doing too well over the years from continuing deforestation and pollution and removal. And with the addition of the 2 hurricanes in 2017, the mangroves have been stressed beyond natural recovery. So my work takes place in the right graph here on St. Thomas at the University of the Virgin Islands campus, which is located under the pink star. Now, going back to the left graph, I want you to notice the spread out of the islands to the right of the purple star. So those are all the Eastern Caribbean islands there. Efficient mangrove restoration techniques are often shared between big projects that take place in places like Belize, Colombia, and Florida. However, restoration practices are not really well shared between the islands there in the Eastern Caribbean just because they're small. They often use different techniques. And again, the information is not shared, so everybody's doing a little something different at different times. Now, it is important to identify the best ways to grow mangroves for our territory, so that way that information can be shared, and those practices can provide guidance for communities in future restoration projects. It can highlight the efficient and effective restoration techniques while reducing time, money, and effort on unsuccessful practices. And that's where I come in. So at the bottom of the screen is my research question that I'm looking into for my thesis, and is how can I grow red mangroves in a nursery setting to maximize growth and minimize costs for restoration planting? So what does this look like? Let's take a look at the next screen. So my research hasn't officially started yet. We're just in the process of building and collecting materials, but I'll walk you through the process. So red mangroves have a seed, which is called the propagule, which you can see is located in step 1. And after that seed or propagule is ripe, what happens is that it'll drop from the parent tree, float in the water, and then when it finds a nice place it thinks it can settle down, it'll start to grow, drop roots, and boom, you have a mangrove tree. However, natural processes don't always happen like that. And as I said, natural regeneration in that way can be hindered with disturbance. So what my project's going to do is we're going to go out and collect ripe propagules that have fallen from the trees into the water, telling us, hey, we're ready to grow, come and collect us. So we're going to take them and put them in pots. And I won't get too much into my experimental design, but then what we're going to do with these pots is then put them in that larger picture down at the bottom right in those blue tubs. So what we built is a closed circuit seawater system that is plumbed with fresh water as well as salt water. So the different salinity levels can be manipulated in each blue tank. And we're going to use different salinity levels as well as shading for the mangroves to see what conditions grow mangroves faster. And then after those mangroves reach a certain size, as you can see in step 4, they're going to be outplanted here in the Caribbean. Next slide, please. So what does all this mean? Well, what I'm looking to do is maximize mangrove growth to better restoration practices here in the US Virgin Islands, to restore our mangrove systems that have been degraded, and also to share that with Caribbean communities as well to enhance everyone's restoration techniques. So by engaging and working alongside our coastal communities, I am hoping again to restore our mangrove ecosystems as well as the services they provide by using mangrove restoration and effective grow out practices. Now I'm going to hand the mic over to Megan so she can talk about some of her research. Thank you.
Thanks, Allison. Hi, everyone. My name is Megan, and I'm an environmental engineering graduate student at USF. And I'm so excited to be here with you all on Earth Day. Here are a few pictures of some of my favorite places on Earth that I have visited. I'm from Washington State, where I studied civil engineering in my undergraduate degree. After college, I served as a Peace Corps volunteer for 2 years in Tanzania, where I taught high school math. That is where many of these photos were taken. Afterwards, I moved to Florida to study environmental engineering, and today I'm going to tell you a little about a project I'm working on right now. So right now I'm working on a hydrodynamic modeling project down in the Manchester waterway. So you might be wondering, what is hydrodynamic modeling? And that is the study of fluids in motion. So hydro, water, fluids, and then dynamic motion. And then why do we do it? To predict how a marine environment will respond to changes. So right now, if you look on the map on the left, if we are up in sunny Tampa, then my research is down about 2 hours south in Port Charlotte. The map on the right is that map. If you get really close in, if you zoom in, you can see there's this community located on the Manchester waterway. The green area on that map is all the vegetation and a lot of mangroves. And then the community is in that upper area, right on the waterway. And then all the dark area surrounding is the water. So down below is the Charlotte Harbor, where people want to get out on their boats to have fun. And then the thin dark area is the Manchester waterway, where they are living. And then these red lines that I've drawn on this map are these cuts that the community is really interested in opening up that land to make better access into the waterway. And there's a few reasons that they want to do that. So they have a couple motivational reasons. The first one is to restore a previous channel. So that top red cut actually used to be open. And it was closed in years ago for construction reasons, and it didn't really serve any great function. So they're looking at opening that one back up. Another motivation is to reduce travel time and distance to the harbor. So right now, people that live way up in the north part of that map, if they want to go out to the harbor on their boat, they will travel down and around all through the waterway to where that current access arrow is to get out to the harbor. And for some people by boat, that will take about an hour and a half. So they would love to reduce that travel time. And that's why they're looking into what would happen if they opened up that waterway. And so there's another motivating factor would be to use less fuel consumption, because if people are traveling by boat for a long time, that's a lot of fuel that they're releasing and using. And then to reduce soil erosion too, because some people, in order to reduce that time, will just fly through that waterway. And that's not great for the environment. And it helps, or it causes erosion too. And then another motivating factor is just to reduce air pollution from boat traffic. So that's what they're looking at doing. And that's where I come in to help see what would happen if they opened up that waterway. And so my 3 questions are, first of all, how does water move within the waterway now, today? So I'm looking at what are the flow trends, how does water move in and out, at what speeds, what direction, where is there fresh water, where is there salt water, all of that. And then my second question is, what will happen to water movement if the water channel is changed? So will the flow directions change? Will the salinity profile change? All those things. And then the third would then be, how will the ecosystem respond to these changes? Next slide. So to start looking at this research, I get to go to the field, which is really exciting, to measure some different components. So what I'm measuring in the field is water level, salinity, speed of flow, and direction of flow. So this picture on the left is a PVC well that I attached to that post. And inside is this little device called a level logger. And it's about this big, it's really small. And it's just dropped in, like you can see in that kind of middle image there. And it stays there, and it will record how water levels change throughout the day and throughout the months over time. So that way we can see like how the water level changes as the tides come in and out. And then these are some other images that I've taken while out in the field. As you can see, lots of mangroves. This whole channel is lined with mangroves, which is really awesome. And that's another reason that we want to make sure that if they were to open it up, it would not harm the ecosystem and harm these mangroves. And so this data that I'm collecting when I go out to the field, I will then put into my modeling software online on my computer and create a simulation that I can then alter. I can look at what will happen if I open a channel alignment, what will happen if there's a storm surge or a hurricane. And then I can also see what would happen if there is sea level rise and all of that. Next. So when looking at this problem, it's really important to consider who is involved in this system, because there's a lot of players that could be affected if we change a whole channel alignment. So the first one would be the community, if you want to click, Heather. And that one is because these are the people that are reaching out to us. These are the people that are interested, and that will definitely be impacted by this channel alignment because they would have new access to waterways. Another group that's involved is marine life. So that could be so many things. That could be fish, dolphins, crabs, but also so many others. I'm sure you can think of many more. And then lastly, we have vegetation. So that can be our seagrasses or, again, mangroves. But there's probably so many more. This is not the only groups that are involved. And it's great to try to think of who else might be impacted from this project. So as we can see, these interconnected systems can be quite complex. That's why it's important to consider the entire system when looking at making changes to the environment to see all who may be impacted. Hydrodynamic modeling is one great way to investigate potential impacts, bad or good, to the system as a whole before taking any action. We need to be thinking about what is best for humans and the earth and how we can achieve a healthy balance. I'm so grateful to be a part of the Strong Coasts team so that I can continue to learn about systems thinking and apply it to this project I'm working on in Charlotte Harbor. And with that, I'm going to pass it over to Addie.
Yeah, thank you, Megan. Can you guys hear? Yeah, okay, I'm unmuted. I didn't know if I was. Hi, everybody. So I'm Addie Buerck. I am a third-year PhD candidate here at USF. And these are just a few photos from different projects and places that I've been for my research and projects that I'm associated with. And so through my undergrad and master's and stuff, I've got the chance to work in Bolivia and Kenya. And now with my PhD research, I'm actually working in Madagascar. And so, can you go to the next one? So to give a little idea of where Madagascar is, if you're not sure, it's off the coast of Africa. And I'm specifically working in a region called Tamasina that is split up into 5 main arrondissements, Fuktan areas. They call their neighborhoods very different things, but it's a coastal city and their main port city there. And so it does not look like Madagascar, the movie there, if that's probably the association you made. But it's a little town coastal, they do a lot of fishing and then transporting things to other areas on the island. And within Madagascar, their drinking water is not readily available at all times. So they do have some piped water, but even if they do have piped water to their house, it isn't always running. And then a lot of people don't have access to that piped water to their house. So they have to use government taps that they would walk to. And some people don't even have government taps within like a 30-minute walk from their house. So it could take a lot of time for some people to get water. And so this created a need for a supplemental water system for these families. And in Madagascar, that commonly takes the form of a pitcher pump. If you go to the next slide, Heather, I think. Yeah, so a pitcher pump is kind of like a hand pump, one that you might see at like a park here, national park or something like that. And these pumps are locally made by technicians from scrap metals, recycled batteries, and then they're also installed. And so it's a shallow ground well. It's easy to put in there since it's really sandy soil. They have a really high water table. And then families can have this put in their yard, and that's what they'll use as their primary drinking water source and cooking, cleaning. So they'll use it for their everyday needs. It's also a cheaper option than buying bottled water or government water and different things like that. So that's a big pull for people as well. And so the issue within this system is that these labeled parts on the diagram are made with lead components. So that's from the recycled battery. So when you think of lead here in the States, you probably think of Flint these days. And so it's kind of the same idea. They have a lead part or pipe within their system, and then that leaches into the water and contaminates it, and then causes a public health crisis because lead's not good for you. And I'll go into that a little bit later. And so it's really unique within this community as well because they don't know that lead's bad. They don't have that education on it. So it's kind of a new concept to them when we go in. And then there's also a lot of cultural aspects to it as well. And so for my project, I'm kind of looking at how do we protect public health and mitigate these impacts, but do it sustainably and without taking away anybody's jobs and things. So I'm kind of working at this intersection between engineering, public health, and social marketing. And so I'll talk about social marketing a little later to tell you what that is. You've probably heard of the other two a little bit. So Heather, if you go to the next one. So from an engineering standpoint, like I was saying, these pump components are put in. So typically it's the leaded weights. And so there's two weights in the pump, and that's what helps create the suction. And so the weights look like this orange circle up there, which that one has like a lot of stuff on it, like buildup and different things, but it's a pure lead weight. And so for our project, we found a replacement. So instead of using lead, they can use iron. And we found that when you take out these lead weights and replace them with an iron weight, you get a substantial drop and there's basically no lead in the water anymore. And so for this part of the project, we have remediated. So we went and actually took these weights out of some of the pumps and did a bunch of water quality testing in the field with our partners, and we're able to get an understanding of, okay, is this actually going to be a solution? And is it applicable? Like, is it something that the technicians are going to be able to do? And so from our initial research, we did find that taking these out creates the change we were wanting. It's relatively easy change because the iron's available or these other metals. It's just was more of a cultural thing. So that's how they were taught to make these pumps. And so that's what they wanted to do. And the lead is easy to melt down and form on the spot. It's shiny, which was a big thing. Some people like the shininess of it instead of maybe like the rusty looking iron that's there. And so we were starting to see a bunch of these other components that came into play, like, oh wow, like we can go in and take these out and it seems pretty easy, but people are putting it back in because they don't understand why we were wanting them to take it out or make this switch. And so that's where social marketing came in. So if you go to the next page. So social marketing is using traditional marketing techniques, but to create a positive decision change. And so within this project, we identified these technicians as our gatekeepers, is what we call them. And so the technicians, since they make these pumps and they install these pumps, they're the ones that can actually make this change. The families, really what they say is, I want a pump, I want it to work, do what you have to do that. So we did a bunch of interviews and surveys with the technicians to understand their thoughts and perceptions. And we actually created this whole campaign and messaging. So this BTTF, that's all in Malagasy. So that's why none of it makes sense if you're looking at some of the words in that. And we worked with our local partners in country to actually implement this. So we implemented this during the pandemic. So it was really interesting since we weren't able to go over during the implementation, but everything was remote. And the idea is that we are helping the technicians step through making this change. So we showed them how to do it. We gave them some practice doing it. They know why they're doing it, and they can continue down the road and see those economic benefits and social benefits. And then to bring the public health side in is lead. As I was saying, it's definitely not good for you. It creates a lot of issues, especially in children under the age of 6. IQ loss, behavior issues, reproductive issues, all sorts of stuff. And so we wanted to get an understanding of, is the lead in the pumps an issue? Is it the only route of exposure? And is there other things that we need to be doing? So we actually created a training and brought some instrumentation over to Madagascar. And we trained local healthcare workers to do some blood level tests for us. So we tested about 400 children in the area through using the lead care system, which uses like a finger prick. And then it's a 3-minute test, put it in the machine, and it tells you what your blood level is. And so then we did this before the study, and now we're going to do it. We did some after, and we're going to see if the water is the only issue. We definitely think there's some other exposure routes that we're noticing, which is not good, but at least now we know about these sources and can keep the families informed on, you need to eat more iron-rich and calcium-rich foods and wash your hands or stay away from these specific regions, things like that, where they could be being exposed. So that's kind of like the big picture overview of the project. There's a lot happening. If you go to the next slide, Heather. It is a huge project. So I just wanted to point out, we have a very large team working on this here in the States, but also in Madagascar on the ground, especially since we can't be there. And I know they are not even all listed here. But these projects, some of them get really large, and it's really fun to get to work with all sorts of different people and partners of different cultures, backgrounds, all sorts of stuff. And so that's what this is. And then another side thing that you get to do, or that I've got to do while in school, is participate in some fun activities. And so one of those was here with a few of my friends in the program, and we entered a video contest. And we actually won first place. Unfortunately, because of the pandemic, we weren't allowed to go. They didn't have the conference that we would have got to go to celebrate. But there's a lot of opportunities to network, win some prizes, different things like that, but have fun and work on other projects as well. So I think we're going to show this video that we made because it kind of goes with the whole Earth Day theme and the EPA.
Now this is a story all about how the EPA came, turned some laws around. I'd like to take a minute, just sit right there. I'll tell you how the EPA clean water and fresh air. In 1970, on a winter day, environmentalists made the EPA. President Nixon was fixing all cool, making environmental protection ground rules. The Clean Air Act was passed to do good, helping kids breathe in the neighborhood. It targets SOx, NOx, and other pollutants in the air, preventing premature deaths and improving welfare. Next on the list was cleaning up waterways, packing up chemicals and keeping them away. The Clean Water Act set wastewater standards, minimizing harmful waterborne hazards.
Yo, this is bad. Are there rules for solid waste we can add?
Resource Conservation and Recovery Act looks exactly at that. Amendment of the Solid Waste Disposal Act, record expands on it, and that's a fact. Cradle to grave, a commonly used term for companies to look at their products long term. Well, the EPA history is long, and I'm telling you just a snippet in its own. The story is just the beginning, so let's find it. We'll get the real
Without the EPA, we would be in trouble. We would look like Mars. We'd probably be headed to Mars.
There would be oil in the waters, and there would be national parks that would be destroyed, and there would be animals that are going extinct because they are getting killed by these disasters that are happening.
You know, sometimes people think that they're going to do the right thing, but sometimes you don't, even when you have the best intention. So I think it's good to have someone else to kind of step in. In the end, it actually is protecting our environment, and not only that, the people. And that's actually something else that I really liked about the EPA. They really focused on people and the environment. Like, you don't have to choose. You can be very focused on what you want to do and the ways that you care for the environment and the ways that you care for people without making them exclusive.
Where would we be without the EPA? Probably where we were 50 years ago, which was our rivers on fire, hazardous waste being dumped everywhere, making communities ill, where we would have air pollution that was much more than we have today. We would have our statues being dissolved because of acid rain. So for the EPA, thankful that it has come into place to protect public health, protect my health, health of family and friends, and something that we definitely want to see more engagement to protect us even more going into the future.
The EPA means to me protection of this beautiful country for the next generations.
So for me, the EPA is very personal because when I was an undergraduate, I actually was an intern at the Environmental Protection Agency. Just the culture of the environment, everyone was so welcoming, so helpful. It was one of the greatest experiences I had in terms of working with the company. So I appreciate the EPA.
The EPA to me means safety, it means healthy, it means protecting everything around us to ensure that our healthy in this world, not just us, but every living thing. I like to dive, and going underwater, you get a better sense, I think, as an environmental engineer, to the work that you do and how important it is to protect environments like the reef environment, which is different than, say, protecting my own health. So actually seeing how wastewater treatment can reduce contaminants that potentially might kill a reef. And lots of that treatment and the targets that you try to get to for what your wastewater effluent might look like, thanks to the EPA for that.
So thank you so much, students, for the Strong Coast students, for sharing all of that, the details about their research. And I know we're almost out of time here. Sorry. So I just wanted to see if we do have any quick questions.
Hey, it's Mrs. Wilkinson. I don't see any questions coming up in the chat. I also just wanted to say thank you so much. I think it's a great opportunity for our students at Stewart, our future engineers, to see the great diversity of what you guys, what they have to look forward to and as this potential field, and that interconnectedness of your different interests and your different practices. So I just wanted to thank you from all of our students here. And if they come up with questions later, can they email you?
Absolutely. Yeah, I was just going to say, if they want to, yeah, you could send them on over and we can just put a document together maybe and share it back with all the answers.
Yeah, that'd be fantastic. So anyone out there, want to come off of mute and just ask a quick question? We do have a couple of seconds. The only thing that kind of popped into my mind, we might not have a lot of time to answer it, and it might have been in one of the slides, was I noticed that in one of the slides there was quite a bit of logos. Are those like sponsors that help fund those projects?
Yeah, I think that was on mine. So yeah, on the bottom, there's a lot of different funding that goes into these projects. So you have to, you want to support the communities you're working in and your local partners, as well as the grad students going through school, and any materials needed. So a lot of those were funding agencies.
Yeah, and you can see on this slide, we always use the NSF, UVI, USF, and then of course our logo. We are funded by NSF. So, you know, yes, and you always want to give a shout out to them, because that we couldn't do our work without the financial support.
Well, thank you again. I know we're about to have a class change over here. So we really appreciate you all coming and talking to us about your environmental projects on Earth Day. Thank you.
No problem. Happy Earth Day, everyone. Thank you so much. And thank you to all the students. Have a great day.
Thank you. Bye.
Thank you. Thank you so much.